everybody. Welcome to Automation in the Age of AI. All right. So my name is Paul Ho. I'm the SE Director for Graphiant. Graphiant is a network-as-a-service company. So we build a multi-tenant network that is global, and we have customers that are connecting to our network. So we help manage a lot of the customers' networks, but the customers also has visibility and manageability of the network, so they have a dashboard to be able to monitor everything. So this session is all about managing the network. It's not about building the network. It's about observability and how do we tune the observability for our customers, but also for ourselves, right? For ourselves to how to make a network troubleshooting easier, how to run the network better. Okay, so there are some guidelines for how we construct our system to be able to better operate the system, right? So you can see here, it's a real-time alerting system. A real-time alerting system, as opposed to a polling system, is where you have a management station that actually goes out and polls the individual devices on a network, which causes delay. A real-time system consumes real-time metrics, real-time data from our devices, from all of the devices from the customer's environment, and uses a streaming processor. It's a state-of-the-art streaming processor that evaluates things in real time. The other things that does is it does a reduction in alert fatigue. Alert fatigue is when you have hundreds and thousands of events that look the same, or that can be coming from many different devices at the same time. These causes a lot of noise, and then you don't really know what you're looking at, right? So these things have to be actionable. What that means is we are creating a system that has a parent-child relationship, ancestor-parent-child relationship, so that many events that happen, we can get to the root cause. So you only get one alert that can potentially represent hundreds or thousands of events that actually happen, or metrics that are happening on the network that can give you then things that are, that you can do auto remediation or recommendations on. Tunable, meaning there's a rules engine that's tied to this, and we expose the rules engines not just to ourselves, but also to our customers, so that you have expert level people for a particular domain of expertise can tune the rules engine. All right, so the rules engine can be improved. So this is part of the learning process for the system to become something that they can turn the system into more intelligent over time. And then wartime drills allows you to run simulations on a network that you can actually improve the system over time. Okay, so the 4 pillars that we're talking about. One is intelligent alerting. Intelligent alerting gives you, the system basically is doing predictable deviations, looking at for deviations from the norm on the network, and it's predicting things that are happening that you should be alerted on, right? It continuously evaluates things, and then it correlates these alerts, so you're not getting alert fatigue when you're monitoring your system. Trigger notifications. So when something does happen, the system triggers an alert, triggers something that notifies you via email, via OpsGenie. So if you're in operations and you're familiar with Atlassian, OpsGenie is part of that system that alerts you. Somebody on call is going to get that alert, and that alert is going to have some auto remediation built into it. So the auto remediation remediates the issue. The system will try to remediate the issue on its own, such as resetting an interface, collecting statistics when something is happening, right? So that the package becomes available. You need it to troubleshoot later, so it's not overwritten. And then it will also make recommendations to the operator who got the alert, like what to do. Okay, that's what we want, right? So it's like something to tell us what to do. Somebody who's looking at, nobody's looking at the screen all the time. You want to get an auto remediation or an alert that tells you, gives you a recommendation. And then finally, troubleshooting. Something when the system can't handle on its own, you need human intervention. We take you to a troubleshooting dashboard where you can triage the issue and then further have a human intervention to fix the issue. Okay, so real quick, It's a great schematic here. It's very busy, but that's essentially you have metrics coming into the system, a streaming engine that comes into the system. You have a rules engine where you can program. So this is part of the programming and part of the learning process for the system. The programming have many conditions. You can and or Boolean conditions that happen, and then that kicks off into what kind of notifications you get and what type of remediation and evaluation that you have to continue doing. So very sophisticated kind of state-of-the-art system that we use, which is also completely open to our customers to program. This is just a canned ruled list, right? So a pre-canned rule list. We're separating things into different planes of importance, right? So we have a systems plane, data plane, control plane. So very clear. So when you have systems plane issues, you have rules that basically says, when do we kick off this rule, at what percentage, when do we kick it off, when do we set the alert, and when do we clear the alert. Here you have also prioritization, notification, and auto remediation. So going into our dashboard, you have data plane, control plane, system plane again, right? And the type of alert and the criticality of the alerts in each of these planes. And as you can see on the bottom, then in a table format, we'll tell you exactly what's wrong on the network and pop those critical ones to the top. Okay. Again, so more of the table format, and then site troubleshooting. You can have a bird's eye view of the entire network. So, we have already tested this and have shown this to be, working for, over 2,000 sites on the same screen, where you can individually pick out your sites where you have issues and zoom in on the different planes of interest, right? So the data plane, control plane, data plane is where your traffic is flowing. Control plane is how the system is communicating with the controller, and then system resources, CPU, memory, and those kind of things on the same screen. And you just kind of zoom into the different lenses of the effect. So, and also in the graphical format on the bottom. So again, site troubleshooting. If you go into system, for example, now in system, very quickly, 2 clicks, you can get into, if you want to look at CPU, want to look at memory on specific sites, you can kind of get to it in 2-3 clicks. Again, zooming down to a site, okay, you have, again, recommendations, what happened, when did it happen, and what's the reason for something that happened on the network. So pretty cool. Then all of this, drill down. This is the 3rd click. You can drill down. You can see what happened last. What was the last reboot that happened on the network? What are your stats? And this is a time series data, right? So you can actually filter in. Did it happen? This is for the last day, but you can filter into the last week, last month. Then you can look at the time series data. Okay, so that was not the demo. So the demo is coming next. So the demo is basically shows you the rules engine. I talked about the rules engine. This is where you set up the rules engine. And you can see all of the kind of very sophisticated and very robust number of rules that you can choose from to kick off alerts that are actionable alerts. Here you can set up suppression. Suppression is to reduce the alert fatigue on a network. You can also set up the time period for evaluation, the levels of evaluation. Kick off an email alert. And also, this is tied into OpsGD. So OpsGD alert, email alert is all tied into this part of the system. If you go into the system dashboard, you have a bird's eye view of the entire system. Now you have all of the different planes of interest, and that allows you to kind of drill down into each one. And you can look at the highest alerts first, right? And then in a busy network, you're going to see green, red, and we'll show you in a few minutes. So here we got an email alert. What are we looking at? We're looking at a system resource. All right, this is already correlated across multiple sites and multiple events. So this one email alert can have thousands of events below it, but the alert, when the operator gets the alert, it's something that he has to do, right? Or he has to be notified on something he has to do. Here we're seeing OpsGenie. The same alert you got in an email, you also get it in OpsGenie. Okay, OpsGenie is where a lot of the kind of the day two operations folks go in and do things that are actionable on the network. OpsGenie actually gives you a recommendation for a URL. You click on the URL, takes you right into the dashboard with a preset filter on where the problems are. You go into the filter, and now you can see even for each alert, right, for each event, you have 79 occurrences for that alert. You're not looking at all of the individual occurrences. These are already correlated into the same place. The next part of this, we're going to cause an artificial a crash on the network. And this crash is, an SMP crash. We just go into a system, cause a crash. Let's see if we see this on the network. And yeah, very simple. And this is one of the drills that you can do, right? And let's test the system. Let's see what happens. So going back to the issue earlier, the system resource issue, you can look at all of the sites on here, and quickly you can say, hey, let's filter out all of the healthy stuff. We don't want to look at the healthy stuff. We want to look at the red stuff, right? What's happening in the red stuff? In the system red stuff. Okay, well, let's drill down into one of them. Yeah, this one says, look like we have very high memory utilization. Let's look at memory utilization over the last month. Well, it looks like the memory is going higher every day over the last month. Looks like we have a memory leak. The memory leak happened on this network, over the last month, and this is since the last time we upgraded. Okay, maybe there's some problem with the code. Let's look at a different location, right? And a different location will show us we also have this issue. So this is apparently for this particular, code version. We are, we may have a memory leak issue in this version of code. So this allows the operator to quickly go back and say, hey, let's roll back the code, or let's upgrade to a code that has a fix for this. So very quick, in a few minutes, you can diagnose the problem, you have a recommendation, and you can move on. Let's go back and look at the crash that we caused. So with the crashes, again, you go into the system. We pick the site that had a crash. In this case, in Geneva, right? Geneva, guess what? Right there, it tells you we had an SNMP crash on the system. All right, and the SNMP crashed on the system. The system auto-recovered by rebooting itself, right? So this is something you set in the rule, how you handle like these crashes or how you handle these events that happen on a network. So part of the auto remediation, system rebooted itself, and now we're recovered again. So and part of that is, the system can also automatically clear the alerts so that once it's recovered, it's already cleared. Okay, so that's the end of the demonstration. Thank you very much. Come see us at Graphiant, booth 607.